So, My Contentions Monday. So, hashtag it down in the bottom, My Contentions Monday, and let me know what your intentions are for this week. What are you going to be getting up to? What ideas do you have? What ideas did you have last week? Let us know and we'll cheer you along. So, as always, don't forget to like, comment, and subscribe to our channel for more topics such as these. Different ideas, different topics. So, anyway, without further ado, let's get on with it. So, in this week's video, I'm going to be talking about dams. And yeah, before everyone sits there and goes, oh no, not a dam. Yeah, dams. You can get 3 lots of power from one dam. How? Well, if you put solar panels down on the slope side, you're generating power from the sun, obviously. If you also fix wind turbines around it, you can also catch wind and you can generate power from wind. And the third way of making power is obviously the dam itself with the turbines, with the water that turns the turbines. Now, I know that a lot of people will, I don't know what the word would be, to be honest. They call it back off a little bit when you mention the word dam because it's risky. It could pose a risk to us. What if it breaks? What happens if, around the world we can see you learn a lot from mistakes that other people make. So one particular mistake that a lot of countries seem to make is they build them and then either they build them in populated areas or they build them and then areas populate around them, and the population of people and animals and wildlife and whatever seems to grow from this. So, with this in mind, I've been thinking of several different ways, by the way. One is building dams that are like steps, and because you have water, if you like, on a river, and it might be deep here, but it's shallow here. Or if you've just had one dam running here, you can have another dam over here. So, a series of dams. And another idea is rather than building them in populated areas, why don't we build them where the sea and the rivers meet each other? So, where you have the end of the river and it starts to go into the sea, if we build great old dams there, wouldn't this eliminate the problem if they ever broke? I mean, this would eliminate a lot of the problems, so that if they did break, let's say, you're not going to build them to break, but let's say it did break and it's out the way. How many people populate those areas where the river meets the sea? Not many. Even if it did bust and it broke, all of this water, well, it just rush out into the sea anyway. Isn't there lots of water there anyway? So I don't see how this would be a problem anymore. Wouldn't it eliminate that problem of the risk factor of whether we make a dam and it bursts and you're at more, so the river's here, the sea, it meets the sea here, and you build the dam here. I mean, and then you have a lot of population that are beside the river and it breaks. It's going to cause massive amounts of devastation, let's say, massive amounts of devastation. But if you built the dam here as opposed to here, and it's already right where the river meets the ocean, and it was to break, meh, who cares? It's not going to affect anybody, so it's not going to endanger anybody's life. It's just going to give a massive burst of water or fresh water into the sea. So I don't see it being that bad. And then you might be like, well, how are we going to build these? How can you build these? Well, that's easy. So if the main river was running over here, you'd build the dam slightly back a bit. And once you've constructed the dam, you then start blocking the river and you allow the flow to go in a different direction. And thus far, keep building your wall if you like. I call it a wall. And then you change the course of the river. So if there was any maintenance work needed to be done on the dam, these parts where you drop in huge bags of gravel, clay, whatever you want to helicopter down, these would be able to be removed very easy. Push a hole through one and the water will move the rest for you. And the river could then continue on its old course and you could then do the maintenance on the dam. And then when you wanted to change the course of the water again, the river, you would then block it off again and the water would then fill and go a different route. and through your dam. And this way I think it has a double benefit that rather than building dams, the power turbines, on the river, in the river, around the river, I think we should build them slightly back and channel a course for where the water is going to run back into the river and basically just manipulate its flow. So if you get what I mean, further back we would then breach the river, so rather than it flowing this way, it now has to flow this way, and it goes into our dam, spills out, and then back into the river again. Now that's manipulating its course, and what you get with this is if you ever needed, or the integrity of the dam started to become weak, or technicians noticed that something wasn't working quite right, you were able to then, with this part where you've deflected the way the river flows, if you just breach that, the river flows back onto its old normal route that it would have done, and then the dam empties. You're able to then get your maintenance work done, everything else, do this, reinforce it, change certain things, and then again block the river so that it has to change its course once again through the dam back onto the course of the river. And I think this way of manipulating the river, the water, to go in your direction that you want it to go, so you can generate power, could it be used as a way of building dams near rivers so that it wouldn't pose a risk to life? So some of them you see that start to overflow because there's been heavy amounts of rainfall. Well, if you've manipulated it in order to change the flow, you've still kept the original riverbed. It's dry, but you've kept it. The water runs a different way. Then you get a high amount of rain, it starts raining loads, the levels start to rise. The overflow would be over here and not over the dam. So you would be able to breach the wall that you've built, your temporary wall to change the flow, breach that, and then your water would just run the normal course on the river. And therefore it wouldn't cause any flooding. You could control it a lot better this way. So not building a dam, let's say, on the river, you build it beside the river and then manipulate the flow so that you can control whether you want that flow or you don't want that flow. You do want the flow, you don't want the flow. And I mean, you could install some equipment to block off the river that you've got on current. It starts to raise and then it finds, water loves to travel, it finds the easiest route. Well, if the current river is flowing this way and it's comfortable to do that, and then you block it, and now this way into our dam is the easiest route of flow, you're kind of fixing a problem there, aren't you? That if anything ever untoward happened to the dam, its integrity, its structural damage, vast amounts of rainfall, you just release the doors again and it will flow in the normal direction it used to flow in, and you've basically made a reservoir because the water will still stay there and probably backflow a little bit. And once it does, it slowly but surely starts to remove the water around the dam area, and then you can get in and do your work. So yeah, I love dams because they generate power whether it's day or night. So if it's day or night, you've constant energy. And I think this helps because it's eco. Okay, yeah, you might have to change the turbines from time to time, that's fair enough. But at the end of the day, it's more eco and it's more better than a solar panel, in essence, because you don't have to wait for the sun to get up. And wind turbines are great, but yes, you could get a windy night, but it's not always guaranteed to be windy. It's not always guaranteed to be sunny. So with that in mind, I think that you are a pain. You are getting a pain in the butt for doing this. Yeah, he's come and say hello on another video. So I don't know, I just think that this way you then get 3 chances of generating electricity, whereas if you had solar panels where you've got one way of getting energy, and it's got to be a good day for it, a good sunny day. And if it's windy and it's not so good for sun, at least you're still catching the energy with the wind turbines that you can build around the structure. And yeah, again, then if you've got water, it's constantly flowing, you might as well use that to power stuff. Now, another one I was talking about was dams in series, or steps. So if you build this dam, and further down the river you build another one, and further down the river you build then another one, you can get this to run in steps, just like steps on your house. So one would be a dam, then another one would fill up, and then it would be another dam and then fill up, and then another dam and fill up. You know, water loves to flow again, so there is the right distance from one dam to another that will enable you to build these dams in series and not. Basically, most people would think that rivers are like tanks of water, which is not true. But if you were to think of a river being like a fish tank, for example, and that you fill it up and it's even all the way across, that's not how rivers work. So where you've got it deep this side in the river, it then starts to become shallow and shallow and shallow and shallower and shallower when you come further and further back. So there is there's math there that you would have the right distance would enable you to allow you to basically make a series of dams. You could make one and it would be nice and deep, overflow, power the turbine, and then it would go back to being thin again. And yes, you would then need to backload the water, but as long as it was the right distance from each other, you would be able to do that. And then it would then start filling up, filling up, filling up, filling up, and then power this dam over here. It's not like a tank of water where you fill it up and it's even. The water is even all the way around the tank unless you've got it on a slant. You've got to think about it. The world, or the planet, is curved, so it's quite hard for people to understand that. You have to take this into consideration when rivers flow. They're constantly. I like to think of rivers like the International Space Station, but on the ground. They're constantly falling, and that's how they work. To my belief system, anyway, it's like the International Space Station that is constantly falling around the planet. And I think rivers do the same thing. So that's why we have different layers and different depths in our rivers. And some part of the river can be deep here, and then it goes really thin, and then it gets deep, and then thin, and then deep. And it's all because of this curvature. You have to add this into your calculations in order to know that if we're on a sphere, you are able then to fill water here, and then as it starts to run, it thins out. But you can then fill it another dam here, and it won't interact with this dam. So, you know, most people think that if you were to put double blockers in, the water would backlog evenly all the way across to the other. It doesn't work like that. It would be more deeper here than it is here. So it's, yes, if you've had them right close together, well, yeah, sure, then it's that each dam is going to interact with the other one, and the time you've built another one, it will stop the other one from working. But with the right distance, and you take into the consideration the curvature of the planet, that's what you get. So anyway, I'm going to pause it here, and then I'm going to flip it over and show you some pictures that I did on a computer. So this one's slightly different. I'm not going to use pencil sketches because they're in a box somewhere in the cupboard, and I still yet got to get out and dig the rest of those out. So I'm almost halfway through my stack of paperwork of drawing and ideas and stuff like that. But these ones are still left in the box. I haven't sorted through those yet. So another time maybe. But these ones are on computer. So from those sketches, this is what I do. So yeah, I'm going to flip it around and I'll see you in a bit. Not the greatest quality in the world, but still it gives you an idea. So I do believe on the other drawing that I did, these were more higher, and this is to let the water in. And as you let the water in, that's what powers your turbines. So again, with building these structures, you'd have the main river that would usually flow this way underneath the screen, let's say. And what you would want to do is manipulate it so that it then block it off here, and then the water comes running in this way. And you'd still keep the original river here. Once it's run through here and it's gone through your dam, you then connect it back to the river. So that if there was any integrity or something went wrong here, all you'd need to do is lower the arm here and allow the river to start flowing in its usual direction. This would act as a holder, and I'm pretty sure that the water would take a little bit more longer to flow back through this way, but it beats the water flowing over the dam. So yeah, I chose steel or titanium, and these would be fixed to piles. If you don't know what piles are, Google them. They're quite interesting. How you get it done with a rig and everything else. So yeah, that's basically where I went with that. And this one would be just to show you the inside of the dam's structure. So we have a bank here. So if the original river would be running here, this would be a side of it, and the arm would be over here. That would allow basically it would either stop the water from going in the normal way from the river, and it would go through your dam and through your turbines, or you'd lower this with an electronic arm maybe, and then the river would flow on its normal course if anything untoward happened within these motor housings or anything else like that. You needed to put some more piles in, the integrity of the structure didn't work too well. Who knows? It beats the water flowing over the dam and then causing further problems. So yeah, and this way can store the water but not have any more pressure put on it if the original river was able to still flow. So this is the final product of what you would see. Again, wind turbines. I don't know if you can make these out too well. They're on my website, so you can check them out there. This is a nice grid of solar panels. Obviously it's slanted, so if we look from the side view, these solar panels sit like this, obviously down the slope. Usually I see a lot of these slopes wasted. I would also be tempted to put some solar panels here as well and use the space there with that slope and this slope down here. And I called this one Freeco, as it's three types of energy: solar panels, wind turbines, and the turbines from the water, generating free eco, so three lots of energy all in one hit, to be honest. So I don't think there are any more. That's something different. So yeah, that's basically where I got with those. But there is another drawing I've got it's still in the pipeline, to be fair. I've not completed it yet, but when I do, I'm going to share that one, and it explains how we can do this in steps. We can make basically one of these, and then further down the river we can then make another one, and then further down the river we could then make another one. So each one would generate copious amounts of energy, and basically if you can convert your whole rivers into a series of dam after dam after dam after dam, thinking the amount of power you could generate is quite a lot. It's extraordinary, to be honest. There was another thing that environmental groups would probably come at you and say, well, what about fish? Because eels most certainly travel upriver. Wouldn't this stop them from traveling upriver? Now you see, the dam itself would, but there is this other invention that I'm adding to the other one that I've come up with that would allow the fish to sidestep these. So you know that you have these areas where deers, badgers and stuff can go underneath these tunnels under main roads, dual carriageways, so that they don't go over the top, they go underneath. There's the same principle that I've used for this, which would allow all basically fish that swim upriver when their breeding times happen. They would be able to use this to sidestep the river, and they wouldn't need to interact with the dam, and they would be able to quite happily find their way through without it affecting the dam and without it causing the water to flow through that channel. It's just too thin for the water to just get large volumes in there. Now, I think that they would prefer to go that way, and I think they would. They're quite intelligent, although most animals are very intelligent, they find a way. So yeah, I think that they would not be impacted by that. So they would still be able to come and go up and down the river, so they could go out back into further downstream into the sea, I don't know, and some that come from that way would be able to come back upstream and still breed and still do what they need to do, and it wouldn't affect them in any way whatsoever having these dams there. So it would make their route more easier. So there is a technique, is a bit of a knack, but it can be done. So, and I will be putting these in my next drawings. So yeah, until then you'll have to keep posted, but yeah, there is a way that we can sidestep it, if you like, Wow, we've got some planes going over. Don't know if you can hear that. I do apologize. Um, so yeah, these dams I think would be pretty good. But generating quite a bit of energy, to be fair. Three types. Nice wind turbines that sat on the top. You know, obviously when you get fast flowing water, especially through turbines, and it starts rushing out this end, I think that there will be an airstream that flies up this way. Waterfalls, anywhere that you've ever been where there's fast flowing water. There's this weir in Thetford. There used to be a Tiffy here in Wyndham, but not so much anymore. I think they've taken it out. But wherever you have fast movement of water, I don't know whether you've ever picked up on that. You get this breeze, quite a strong breeze come from off of the any water that moves fast. If you have your shower on in your power shower in your house, you notice if you stand slightly away from it and you have the cold water running rather than the hot, you can feel a breeze. It almost generates like a quite a strong breeze. Considering it's just a power shower, the same thing will happen with these, and that is why the wind turbines are sat up here. There's one in the middle here, although it's not very clear on here, to be fair. Not really picking it up. So there's one here, one here, one here. There's one down here, one here, and there was also one over here and one over here. And that wind that is going to be generated off of the water moving fast will power the generators on the wind turbines to give even more power, I believe. So, and even if it's a windy day, the wind will slide up here because it's quite aerodynamic, because like I said, it's on a curve. So yeah, that's basically it for this one. It's just a really quick video on this one. I wanted to get this one out of the way because every time you mention dam to people, they are not very confident with them because of the they'll always bring up China, the China dam, the dam in China. There was a dam in France, I believe it was, somewhere Italy maybe, that also had some problems, technical issues, that they started building one there, but there was some integrity issues with that. Again, we could build these right before, so if the ocean was over here and it would be right at the end of the river, we could build a lot of these at the end of all rivers and take it in steps. And then if they were to break, which again, we can always find a way around this breaking problem. If there's a lot of water here and you have some increased rain, like I said, just keep it beside the old river and basically just manipulate the flow of the water. So usually the water would flow this way, but if we put something here, an arm, a mechanical arm that opens and closes, it can fill this bit. But if we have a large amount of rain or the integrity of this is becoming not good, we can take the pressure off of it by opening this gate, and the water would just run on its normal course, and then slowly but surely this would then trickle back into the river. We could control the flow here by shutting it off using these ones. Drop these down and open the gate here. These would then stop putting out their water. The river would continue on its normal path like it always used to. The water that has been bulk would stay here, and slowly but surely, if we opened these just a minute amount, we'd be able to then turn on the water, which would then be able to come out of here and feed onto the river so that we don't flood any neighbouring houses, villages, cities, whatever may lay in the wake of this if it was to burst. And then slowly but surely this level would start to dry up. The river would go on its normal course, and then yes, technical work could be done to fix the problem. And then yeah, I don't know, I think most dams are built on the actual river, and when there's a problem, is it a wonder that is it going to be a big problem? Well yes, because you've built it on the main river. Where else is that water going to go? Well, it's got nowhere to go apart from this way, whereas this one has two ways to go. It can go on its normal course, which we stopped and just manipulated the flow. So we have this much of the river that is the old way the river used to flow, and now we've created this diversion. So we've just diverted the water, run through our turbines and then back into the main river. If there were any problems, we could just lower these and the river would continue to flow like it used to before we built the dam, rather than having the dam where there was only this way out and this way in. So if there ever was a problem, the only thing that you can do is basically wait for this to break, and then whoosh, a large volume of water will go and flood everything. This way eliminates that problem. There's always a way around this type of situation to stop big problems from happening, and what you have to do is you have to think about the problems that could happen and basically implement them into your ideas. And that way, what you get is, I wouldn't say fail safe, but it's definitely a lot of contingent. You've basically, forget that word, I tried chewing on it. You've basically got a backup that if something was to go wrong, what do we do? Well, step number one, we lower these, okay? And then we lower these arms here, okay? That allows the river to flow on its normal course like it did before we built the dam. Okay, step two is slowly start draining this into the river so that the river will be a slight bit more full than it usually is, but it's not all of that water going all at once. We are doing it. Step two would be to release some of this water back into the river itself. Step three is slowly but surely, once this has started to become like it's draining, is monitor it until this dries up. Then step four would be basically fix whatever your problems were with inside the structure. And step four is assess and test. Again, assess the situation. Is it going to happen again? Well, it might. How successful was it at letting the water out? Always check your fail safes of how successful they were. Yes, it worked really well. Okay, brilliant. Then you have this understanding, not just I know how, you know how to build a dam. Great. But now you have this understanding of what to do if this was to ever go wrong. How could we get rid of this water in a safe way that doesn't affect the integrity of the overall dam, and it doesn't affect the integrity of the river's natural flow? And I think this is the best way forward, basically, and yeah, using a lot of forward thinking. We don't ever want there to be a problem with this dam. However, if there was a problem with the dam, let's say an earthquake happened and it caused a nice split or a tear in through here, well, we're going to have to deal with that. We can take the pressure off. No, it's not going to go anywhere. And then we're able to deal with the problems as they come. Anyway, so as I say, this is just a quick video on that. So let me know what you think about this. Have I missed anything? Have I overlooked anything? Would this reassure you if this dam was built near you? Would it make you feel more reassured that there is a backup? There is a way that we can overcome any problems that this may run into. So let me know your thoughts in the comments. Like the video if you like it. Remember, this is just, stage one. I have another couple more drawings to go on the next version of this, where they run in steps. And basically there are one dam after another dam after another dam. That one is also on my website, but it was more for a pit. Basically, if we've got pits, we can just recirculate the water. Keeping water circulating basically stops it from becoming stagnant when you keep water moving quite fast, because it mixes a lot of air into the water and it stops this algae bloom, let's say. So it stops things from becoming stagnant and that horrible stench you get with stagnated water. So yeah, anyway, that will come in another video, but this one's just a quick one for this. So yeah, if it's not so clear on here, again, check out my website. This one is on there and you can see it all. Probably be able to zoom in and do all sorts of weird and wonderful stuff. So yeah. Oh, I didn't know you could do that. That's very nice. So yeah, you can see the turbines on the top there now, a little bit more clearer. See, there's one in the middle there. Nice, nice, nice. Another one there. So yeah, they're your solar panels. Awesome. Didn't know that. I'll remember that for next time. Kind of zooms in quite a bit. That's nice. So yeah, basically, that's how it would be. So whatever you're doing, let me know. If you're up to anything good or interesting this week, we'll cheer you along. And I will catch you in the next video. So I'm going to make a couple more, but hopefully we'll get them done for Friday. I was meant to do them this Friday. This video was a video for Friday, but it just wasn't in it. I just wasn't right in it, let's say. I wasn't feeling it. So this week is going to be catch up. So a couple more on ozone making, and also taking pollution and use an electrolysis process to try and separate carbon monoxide and carbon dioxide. So we'll be looking at those in the next videos, hopefully. So until then, I'll catch you in the next one. Take care. Bye bye.